We're finishing Goal 18 with 2 examples, and we are graphing cotangent. Let's begin with example 1 by identifying A. The coefficient of cotangent is 2. B. The coefficient of x is 1/4. So to calculate the period, we divide pi by the absolute value of b. So that's pi times the reciprocal of 1/4 is 4. So our period is 4 pi. Okay, well with tangent, remember that our asymptotes were at odd multiples of pi over 2, but with cotangent, our asymptotes are at integer multiples of pi. So we will always use 0 and pi as the asymptotes for the parent function of tangent. So if 0 and pi are the asymptotes for the parent function of tangent, we will place any horizontal transformations between 0 and pi and then isolate x. So to do that, I will multiply each term by 4. We can see that our period is still, or confirms 4 pi radians, because if we begin at 0, we will end at 4 pi. So these are our asymptotes when we stretch that period. So let's try to sketch this. Remember, I'll put positive A and negative A on the y-axis. And then my endpoints, my midpoint, and then mark the quarter marks. So we should have asymptotes at 0 and 4 pi. Now recall, tangent rises to the right, so its reciprocal, cotangent, falls to the right. So we should have positive 2, 0, and negative 2 for this first period for cotangent. I've asked you to sketch 2 periods of the function, so let's sketch our second period to the right. And remember, when we sketch to the right, then we will add the period length. When we sketch to the left, we subtract the period length. So 4 pi plus 4 pi is 8 pi. So our next period ends at 8 pi. And then we have our midpoint and our quarter marks, 2, 0, and negative 2. With example 2, it looks like I forgot to type the word cotangent. So if you will do that right now, please. Okay, so let's identify A. A is -1. B is 3. So that helps me calculate my period of 2 pi over 3. So it is going to shrink the period, but we're also going to have a phase shift. So remember, for cotangent, the asymptotes of the parent function, we're using 0 to pi. So we will place all horizontal transformations between 0 and pi. And I do want to sweep the fractions, so I'm going to multiply each term by 2. And I'm using 2 because that's my least common denominator. So we have 0 is less than 6x minus pi is less than 2 pi. And now I'll add pi to the middle and on both ends. And then I'll divide through by 6. So one asymptote is at pi over 6, and the other is at pi over 2. And then just to confirm that I've done my math correctly, I do want to find the distance between these two asymptotes and make sure that they are 2 pi over 3. So I would subtract these. So pi over 2, or 3 pi over 6, which is equivalent to pi over 2, minus 1 pi over 6 does give me 2 pi over 6, and I have pi over 3. So I'm seeing that I made a calculation error somewhere. Let's go back through and double check. Okay, I just caught my mistake. All this math is correct, but it's my period that's incorrect. And I'm kind of glad I made this mistake because I see students make this a lot. We are so used to graphing sine and cosine because that's what we start with. Sine, cosine, secant, and cosecant always calculate period as 2 pi over b. But remember that tangent and cotangent's periods always repeat every 1 pi radians. So that was the mistake there. So be careful of that you don't do what I just did. So the period for cotangent is 1 pi over b, and in this case, pi over 3. So that does match the math here. Okay. You probably caught that when I did it, and I apologize. So let's place our asymptotes of pi over 6. And we also are going to have the other asymptote as pi over 2. So I'm going to count that out. This is 1 pi over 6, 2 pi over 6, 3 pi over 6, which reduces to pi over 2. And remember that I have these asymptotes because I set all horizontal transformations between 0 and pi right back here at the beginning. This is cotangent. However, A was a negative value, which tells me I'm going to have a vertical reflection. We know that cotangent normally falls to the right, but because we have a vertical reflection, this will rise to the right. So at my first quarter mark, I'll be at the negative value of A, or negative 1, 0, and then positive 1. And let's draw our second period to the left. So recall, we will take our asymptote, our end point here, and we will subtract the period length. So I will subtract pi over 3. My common denominator is 6. 3 will divide into 6 twice, so this would be subtracting 2 pi or negative pi over 6. And again, negative A, 0, and positive A.